The section 3 of chapter 4, equation of state, is about Vinet's equation of state. This is the form of Vinet's equation of state. Pressure is equal to 3 times the isothermal bulk modulus at 0 pressure, kT0, times minus 2 over 3 power of V over V0 times 1 minus 1 over 3 power of V over V0 times exponential function of 3 over 2 times kT0 prime, the pressure derivative of isothermal bulk modulus at ambient pressure, minus 1 times 1 minus 1 over 3 power of V over V0, equation 4.1.9. We derive this equation of state in the following flow. First, we assume a form of Helmholtz free energy as a function of volume. Then, we obtain a formula of pressure as a function of volume V with kT0 and kT0 prime by differentiating Helmholtz free energy by volume. We obtain the kT by multiplying the volume derivative of pressure by volume, and obtain kT0 by substituting V equal V0 into the formula of step 3. We obtain kT prime from kT by differentiating with respect to pressure, and we obtain kT0 prime by substituting V equal V0 into the formula in step 5. Then we substitute kT0 and kT0 prime from the formulas step 4 and 6 into the formula of pressure in step 2. Then let us consider the formula of the Helmholtz free energy. The starting point of this argument is from this diagram. This is a diagram of the scaled atomic binding energy against the scaled atomic separation. These are substances: silicon, hydrogen, and oxygen, rubidium, lithium, sodium, potassium, cesium, and hydrogen. You can see all data lies on this curve, and this curve is the formula of this curve is F0 times 1 plus A times exponential function of minus A. A is scaled atomic distance, R is interatomic distances at high pressure P, and R0 is interatomic distance at 0 pressure, and L is scaling length. This is from Rose 1983 and Vinet 1983. They derive Vinet's equation of state from this form of the atomic binding energy. Then here we assume that the Helmholtz free energy F is proportional to the atomic binding energy. Therefore, Helmholtz free energy F has a similar formula to equation 4.3.1, namely Fa is equal to F0 times 1 plus A times exponential function minus A, and the parameter A is equal to R minus R0 over L. We replace A by R equal R0 over L. Then we have a Helmholtz free energy as a function of the atomic distance R, which is equal to F0 times 1 plus R minus R0 over L times exponential function of minus R equal R over minus R0 over L. Then we assume that the atomic distance R is proportional to the volume at high pressure volume. Then we express the Helmholtz free energy as a function of the volume as F0 times 1 plus V over 1 over 3 power of V minus 1 over 3 power of V0 over L. V equal volume at high pressure and V0 equal volume at ambient pressure times exponential function of minus 1 over 3 power of volume minus 1 over 3 power of V0 over L. Here we assume the V, we replace V by R cubed and V0 by R0 cubed. Then we obtain pressure by differentiating Helmholtz free energy with respect to the volume V and multiply by and minus sign, then which is equal to minus F0 times the derivative of former factor times latter factor plus the former factor and derivative of latter factor. Then we calculate and simplify, and we obtain the pressure is equal to minus F0 over 3L squared times minus 2 over 3 power of volume V times 1 over 3 power of volume at ambient pressure V0 minus 1 over 3 power of volume at high pressure times exponential function of 1 over 3 power of V0 minus 1 over 3 power of V over L. Equation 4.3.5. The equation 4.3.5 is already Vinet's equation of state. However, the parameter F0 and L are unknown. We need to express this equation of state not using F0 and L, but using the macroscopic parameters, namely KT0 and KT0 prime. We first obtain KT0 here. So the definition of a KT is minus V times round P over round V at T. Therefore, first obtain round P over round V at T. Therefore, we differentiate the Vinet's equation of state with respect to volume. Then the calculation is complicated, but we obtain this formula. And using this formula, KT, the isothermal bulk modulus, is minus V times round P over round V at T. Then it becomes like this. Then KT0 is KT at zero pressure, namely volume is V0. Then we substitute V0 into a V. Then we obtain the isothermal bulk modulus at zero pressure is equal to F0 over 9L squared times minus 1 over 3 power of V0. Equation 4.3.8. Next, let us obtain KT0 prime. We differentiate KT with respect to pressure at constant temperature. Then, because of the chain rule, this is equal to round KT over round V times round V over round P. We have already obtained round P over round V in the previous slide. Therefore, we express kt prime by round kt over round V at t divided by round P over round V at t. Then we first obtain this red part, differentiate the isothermal bulk modulus by with respect to volume V, and we have this formula. Then kt prime is equal to this formula divided by the pressure derivative of volume derivative of pressure with respect to time, temperature, this form. Then kt prime is this form. Then we substitute v equal v0. Then we have kt0 prime is equal to 1 plus 2 over 3L times 1 over 3 power of v0. Equation 4.3.12. Then we modify the formula of equation 4.3.5. P equals F0 over K 3L squared minus 2 over 3 power of V times 1 over 3 power of V0 minus 1 over 3 power of V times exponential function of 1 over 3 power of V0 minus 1 over 3 power of V over L as 3 times F0 over 9L V0 1 over 3 power of V0 times minus 2 over 3 power of V over V0 times 1 minus 1 over 3 power of V over V0 times exponential function of 3 over 2 times 2 times 1 over 3 power of V0 over 3L times 1 minus 1 over 3 power of V over V0. Why we modify in this way? This red part is equal to kt0 and this green part is equal corresponds to kt0 prime minus 1. As a result, we have the Vinet's equation of state. P equals 3 times kt0 times minus 2 over 3 power of V over V0 times 1 minus 1 over 3 power of V0 times exponential function of 3 over 2 power of kt0 prime minus 1 times 1 minus 1 over 3 power of V over V0. Equation 4.1.9. So we derive the Vinet's equation of state. We will compare Vinet's equation of state and Boltzmann equation of state in the later section. Therefore, let me stop this section, end this section here.